Welcome to Podcast Learning Fun. Today, we're going to be looking at the quantum world,
Okay.
specifically something called the commutator.
Ah,
Yes, now I know that might sound,
a little intimidating.
yeah, like something out of Star Wars, but
Right.
it's really key to understanding one of the most mind-bending principles in physics,
Yeah,
the Heisenberg uncertainty principle.
absolutely. It's all about how actions or measurements interact with each other in the quantum world.
Okay.
So imagine you've got two actions, A and B.
Okay.
Now, in everyday life, the order we do these actions might not matter.
Right.
Like making coffee, then grabbing your keys versus grabbing your keys and then making coffee.
Yeah,
Same result.
exactly.
But in the quantum world,
Oh,
the order can drastically change what happens.
really?
And that's where the commutator comes in.
So it's like a cosmic traffic cop
I like that.
for quantum actions.
It tells us if the order of those actions actually matters.
Right.
And get this, sometimes just measuring one thing can make another thing uncertain. It's like trying to take a picture of a hummingbird in flight.
Okay.
You snap the picture with a flash and you might scare it away, blurring the image.
So you're saying just by looking at something in the quantum world,
Yeah.
we're actually changing it.
Exactly. One of the most famous examples of this is the relationship between a particle's position and its momentum.
Okay.
And momentum just means how fast something's moving and in what direction.
Gotcha.
Now, you'd think we could measure both of those things really precisely,
Yeah.
but the universe has other plans.
Uh-oh.
So the more we try to pinpoint a particle's location,
Yeah.
the less we know about how fast it's moving and vice versa.
So it's like a trade-off.
It's like they're linked in a weird way.
Wow.
And this is where the Heisenberg uncertainty principle comes in.
Okay.
It says there's a fundamental limit to how accurately we can know both a particle's position and its momentum at the same time.
So you're telling me it's not just our instruments that are limited?
No.
There's like a fuzziness to reality itself.
Yeah, the universe isn't like a perfect clockwork mechanism.
Okay.
It's more like a constantly shifting kaleidoscope where certain pairs of property, like
Position and momentum.
exactly, are just fundamentally intertwined in this blurry dance of uncertainty.
That's kind of a beautiful way to put it.
Thanks.
So this uncertainty isn't a flaw, it's just like a feature.
Absolutely, a fundamental feature of the universe.
Wow.
And it's not just limited to position and momentum. Other pairs of properties, like different components of angular momentum, also show this non-commutativity.
What?
Yeah, it's like a cosmic rule that keeps the quantum world shrouded in this veil of uncertainty.
Okay, my brain is officially doing backflips.
It's wild stuff.
But why can't we measure these things simultaneously?
That's a great question.
Is it our technology or is there something deeper going on?
That's where it gets really interesting.
Okay.
It all comes down to the act of measurement itself in the quantum world.
Okay.
When we try to observe a quantum system, we inevitably disturb it. It's not that our instruments are clumsy, it's deeper than that.
Oh,
Imagine you have this perfectly still pond,
okay.
reflecting the world around it like a mirror.
I'm picturing it.
Now imagine you toss a pebble into that pond,
Okay.
ripples spread out,
Yeah,
and distort the reflection.
right.
That's kind of what happens when we measure something in the quantum world.
Oh,
Our active measurement is like that pebble creating ripples of uncertainty.
so we can't just peek into the quantum world
Not passively, no.
without messing things up.
Exactly. The very act of observation is a form of participation.
Ah,
And this has profound consequences, especially when dealing with those non-commuting quantities.
like angular momentum.
Precisely, angular momentum, as we said, is about how things spin.
Right.
But in the quantum world, it's not just a simple spinning motion like a top.
Okay.
It's quantized, meaning it can only take on specific discrete values.
Huh.
It's like a spinning wheel that clicks into certain positions instead of rotating smoothly.
Okay, I can picture that.
And to make things even more interesting, we can't know all the components of angular momentum with perfect accuracy at the same time.
Seriously?
It's like trying to pin down a spinning coin on its edge.
Oh,
The more you try to force it to land on heads, the more it might flip to tails.
because by measuring one component, you're messing with the others.
Exactly. They're intertwined in this quantum dance linked by those non-commuting operators.
Wow.
The more we try to pin down one component, the fuzzier the others become.
So it's a fundamental limit.
It's baked into reality itself.
This is blowing my mind.
It's wild stuff.
But is there any way around this?
That's the million-dollar question.
Yeah.
And one that has puzzled physicists for generations.
So
The short answer is no.
we're stuck.
Well, Stuck might not be the right word.
Okay.
This uncertainty isn't necessarily a bad thing.
Oh.
In fact, it's what gives rise to some of the most mind-boggling phenomena in the quantum world.
Like?
Things like quantum tunneling and entanglement, which have the potential to completely revolutionize technology as we know it.
So it's like the universe is saying you can't know everything for sure.
Yeah.
But here's some superpowers.
Exactly. And it's by embracing this inherent uncertainty, by understanding the language of commutators and the dance of non-commuting quantities, that we can start to unlock the true potential of the quantum world.
This has been an incredible journey so far.
It's just the beginning.
But I have to ask, what are the implications of all this?
That's a great question.
How does this quantum weirdness affect our everyday world?
Well, that's where it gets really exciting. Even though the quantum world seems strange and counterintuitive, it's the foundation for everything around us.
Right.
The very fact that atoms exist, that molecules form, that light interacts with matter, it all boils down to the principles of quantum mechanics.
So even though we don't see this uncertainty directly,
Right.
it's still shaping our reality.
Precisely. And as we delve deeper into the quantum realm, who knows what new discoveries await us?
Good.
Perhaps we'll uncover new technologies, new forms of energy, or even new ways of understanding the very nature of reality itself.
It's both humbling and exhilarating.
It truly is. And the